Welcome to Saravji. Today's topic is an educational talk about feature selection and feature engineering and why it matters. In this part, I'll cover the overview. So I spent some time exploring why feature selection and feature engineering matter because I'm always curious about where to spend time efficiently. So not wasting time, but spending it intelligently and efficiently. So I was wondering, where is time best spent in a machine learning pipeline? Starting from data ingestion, which is time that is required, but then actually spending time on feature selection, feature engineering, tuning the algorithm, and so on, and fine-tuning the programming. So these is my answer why feature selection and feature engineering matter. And in case you don't want to trust me, just trust those folks. There is quite some knowledgeable folks in there. In the deck, the links are actually in there where these answers are coming from. The syllabus that we're going to be following is the welcome that we had. Then in this deck are going to be all the links, the methodology that I'm using, the data that I'm using, and then actually diving into the parts of feature selection and feature engineering. Here are the links. Either take a screenshot or go. You actually only need this one here. So the moment you actually go here or go down from Saravji's hut, go down into the data science machine learning one, feature selection, feature engineering one, you will find this presentation with all the links available to you. So the methodology I'm using to actually evaluate that is I needed to evaluate the contribution of the individual components so that I could isolate what component is contributing how much, and by modifying this component I could assess what the effect is. And to kind of create a neutral picture, I went into scikit-learn and selected randomly one machine learning algorithm out of the machine learning groupings in scikit-learn. Now this experiment was done on a little bit older version of the scikit-learn package, so I have referenced it here. What exactly I'm actually talking about with those groupings. And unless tuning of the algorithm is actually part of the experiment, I am using the default settings for all the machine learning algorithms, how they're actually configured in scikit-learn, with the one constant exception is that I'm using a random seed. I'm setting the random seed to ensure comparability and repeatability across all the experiments so that we actually can compare what is going on here. As for the dataset that I'm using, it's the MADELON dataset. This is a synthetically created dataset for the distinct purpose of demonstrating and experimenting and evaluating feature selection and feature engineering performance of a pipeline or an algorithm. It was created by Isabelle Guyon, and she is part of the inventor team of the SVM RFE approach. The dataset itself consists of 2,000 training observations across 500 features, and all observations are integers in the range from 0 to 1,000, and there is a target value in there, a target column in there that is either -1 or 1. So it's a two-class problem, classification problem. Additionally, there are 600 test observations that are exactly done in the same manner that can be used for evaluating the performance of the algorithm. So the data set actually comes already separated in these two data sets. Again, the details are linked here. And with this, I'm concluding the overview.